Okay, here I'm going to go over 4-1 area models. This should be review, but for any students who are feeling like unsure of themselves, this is your moment to get more thorough explanation. So, first things first, I want to remind us that when we're working with area models, what we're actually doing is thinking about it as the area of a rectangle. So we want to keep in mind the area of a rectangle formula. So let me just type this out, area of rectangle. And the area of a rectangle formula can be thought of like area equals length times width. So I'm going to refer back to this a bit as I go through these problems. So part A, examine the area tile rectangle at right. Write an equation showing the area as a product is equal to the area as a sum. So in order to do this, we need to have both the inside of this rectangle filled in, and we need to have the length and the width, the edges. So I'm going to start with the inside. So this larger square is x by x, but all these like longer squares are an x by 1, and inside, inside, they are all going to represent an area of x units, some unknown units, but they're the same as each other. And then the edge lengths of these are x by 1 in terms of their dimensions. So all these little ones are 1 by 1. So there's our inside information. Now let's get our length and width on the outside. So I'm going to do this in pink. So the larger square, x squared, is a product of x times x along the edges. And then to get the other parts of the inside using a product, I noticed that this little edge here is x, which means that this length is also x. So the only way I can get x as a product with x as one of the factors is by 1. So x times 1 makes x. So that little section would also be a 1, and then these would also be 1s. And that works out nicely because 1 times 1 would give us each of these littler squares up here in the right, on top right. I have everything I need now to be able to show that the area as a product is equal to the area as a sum. So remember our formula, area equals the length times the width. So what I'm going to do here is on the left-hand side, I'm going to write out the area of the inside of this figure, but like combine all my terms, everything inside. So I have an x squared right here. I'll start with that. And then I have 1, 2, 3, 4, 5 x's, so plus 5x. And then I have 1, 2, 3, 4, 5, 6 ones, so that's plus 6. That is the inside area, but the area is equivalent to the length times the width. So now I'm going to get my edge lengths to be my length and width. So along the bottom, I have an x and a 1 and a 1. So my length is x plus 1 plus 1, which is x plus 2. And my width, my vertical length here, x plus 1 plus 1 plus 1 would be an x plus 3. So just to recap, this part right here is the area as a sum, and this part right here is the area as a product. And they are equivalent because it's all coming from that area model, or that area equation, excuse me. Now I'm going to go quickly through part B. So I'm trying to multiply 6x minus 1 times 3x plus 2 using this area model. And 6x minus 1 times 3x plus 2, this represents our length and our width of a rectangle. So I'm going to go ahead and put 6x and negative 1 in the 2 spots along the bottom. And then 3x and 2 along the edge. And then, so that's our product. And now what we need to do is fill in the inside in order to write this answer as a sum. So I multiply the side lengths to get the inside parts. So 3x by 6x would be 18x squared here. And then 2 times 6x would be 12x. Here we have 3x times negative 1 is negative 3x. And here 2 times negative 1 is negative 2. So the final thing to do would be to write out the inside as an expression. So we have 18x squared. We always like to start with the term with the highest exponent. And then 12x and negative 3x actually can be combined because they're like terms. So 12x minus 3x is 9x. And then finally our constant minus 2. And there is our answer as a sum.